All right. What we just made was a theoretical probability distribution. If we want to make an experimental probability distribution, we have to run an experiment. And experiment probability distributions will not always match the theoretical exactly. But it's one of those things. It will be close, kinda. Let's take a look here. Um, Example 3, we're going to construct a relative frequency table. Um, so x represents the sum of the values of rolling two dice. So we're going to run this experiment. You can literally grab two dice from like Monopoly or some random dice you have around your house and roll your dice 100 times, and let's see what you get. And I'm going to double check here real quick to make sure that it's like I'm using a table that the book has got, so I don't have to make you watch me roll 100 dice on my on my screen here, because that would be pretty boring. I mean, it's already boring enough watching me uh, check up and make sure that the sum of all of these frequencies right here is 100. That means that they roll it 100 times. Um, Now, if you want to be able to roll 100 dice without actually having to roll it, I've got a link, and I'll include this in the assignment as well. This actually opens up a website that will allow you to roll 2d6, and you can go ahead and go over here and click on the roller button, and I want to output 100 rolls. So I click roll, and look at that. It's got 100 rolls for me and their sum. So all I would have to do is take a look at those and make a table of what it is. Make a tally mark in the 6, make a tally mark in the 12, make a tally mark in the 6, make a tally mark in the 7, and then in the 3, and then back in the 7, and then back in the 12. You get the idea. It's up to you on what you want to do. If it asks you to make an experiment about rolling dice or flipping coins, you can do it, or you can find some sort of um, calculators online. There's all kinds of random number generators. Another one that I actually really like is random.org. There are some free ones in there. You can do lottery quick picks, coin flippers. They have a dice roller, but it only allows you to do roll two virtual dice. It just allows you to do two at a time. But you can see it just rolls the dice and gives you random things, and you would just have to add it up yourself. It's your choice if you want to run that experiment. I am going to do this with the table that they gave me. So I want to construct a relative frequency table. That's pretty much what we've done here. Before, on the last one, when I was looking at the relative frequency, I put them all in fraction form with the 36. Here, all of these numbers, if you think about it, they're all out of 100 for the probability. I'm not actually going to put them out of 100 though. I just want the frequency. I just want the number of tallies. If it said they rolled a 3 5 times, I just care about that number 5. I don't want the fraction. Think of it, I just want the numerator. Now we are going to graph that, just like we did in the last one. So I need shape, some axes here. Oh, I kind of actually want that to be black. I don't want that to be red there. Now, one thing that's good to look at is what is the maximum value here? It probably should be the 7, and it is. It's 22, 12, 11, and 14. Those are all pretty close to it. So I really only have to get up to 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I've got 10, if I go up 2 at a time, 4, 6, 8, 10, 12, 14, 16, 18, 20. The next one up would be 22. I'm going to slide all that down just a smidge and stretch that out. And now I've got all the way up to my 22. Excuse me. And this time I'm actually going to make my marks in between a little bit wider. And I'm going to kind of like the whole box is going to be the 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, I need it to be a little bit wider. So that way I can just fill up the box on, or the boxes for um, for the bar graphs instead of having to draw them by hand. So all I'm going to do here is take a look at the table. For 2, it had a frequency of 2. And I like to start off, I'm just going to put the tops in. 3 had 5, which would be halfway right there. 4 had 6. 5 had 13. Ooh, all the way up here. 6 had 14. And 7 had 22. That's the one way up here at the top. Oop, let's line that up over the 7. I'm just marking off the tops in all these. That's the way I kind of like to do these bar graphs. Let's see, 8 is 12. 8 is 12. 9 is 11. 10 is 8. 11 is 3. And 12 is 4. So now I just... The little bit of spacing on the graphs makes things a little bit nicer sometimes. And it's kind of your choice on how you want to do these histograms. You can have them where they're touching, or you can have them separate. All right. Now, is this shape exactly the same as what we had before? No. But is it pretty close? Yeah, it's not too bad. 7 is definitely the most popular. The 12 and the 2 are basically the least popular, though there's some oddballs here like the 11. It should probably be, about in this range, and maybe the 7 should be a little bit shorter, and maybe a little bit taller here for this guy. So you can see there's a theoretical one that's a little bit shorter there, but that's the thing. The experiment is going to be different than the theoretical because it's not going to be perfect all the time. Though there is one thing called the law of large numbers. Now, this was only 100 dice rolls. Imagine if we had done 100,000 dice rolls. Do you think that it would be closer to the look of what the theoretical probability would be? Yeah. If you did 100 million, it would definitely look closer, right? So the idea is the law of large number, the variation in the data set decreases as the sample size increases. So as the numbers get bigger and bigger and bigger, you will get closer and closer and closer to the theoretical probability with your experimental data. Which is why when someone is doing a science experiment, they don't test it on 10 things. Maybe they do it first, but they do more and more. When we tested the COVID vaccine, we didn't test it on 2 people. Oh, good job, you 2 didn't get sick. We tested it on 2,000 people. 1,000 people got it, 1,000 people didn't get it, and then we said, hey, did those 1,000 people who actually got it and didn't get the placebo, did they do better than everyone else? Yeah. Now, other studies, they'll work on even more people, but there's actually a rule to figure out how many people you need to find it on to get a confidence interval of something that you accept, which you'll actually learn about later in this chapter. But that's the big thing. Law of large numbers. The more experiments you do, the closer you get to the theoretical.